welcome to Lock That Shit Down. This is a presentation about auth patterns for apps, APIs, and infra. This is my colleague, Brian Demers. You can say it Demers if you want, but it's wrong.
It's Demers.
My name is Matt Raible. I'm a hick from the sticks. Brian's into beekeeping. I'm into classic Volkswagens. We have dueling clickers here.
Yeah,
so.
yeah. They have laser pointers too,
Yours isn't
right?
working?
Well, I think it's working.
All right. So today's agenda. I'm gonna make it so we can see the slides a little better here.
Yeah, good call.
We're gonna talk about what is auth, and the reason we don't call it auth-n or auth-z is because we want to actually encapsulate both of those terms. And then we're gonna talk about app security patterns. So this is like SPAs and mobile apps and server-side apps. And then API auth security patterns. Infra auth security patterns, we'll get into things like Linux and Docker. And then we'll wrap it all up at the end, telling you to take some action and what we think that you should do to make your systems more secure.
Next slide.
Next slide.
So what is auth, right? So Matt sort of hinted we don't really talk about auth-n or auth-z, but for most app developers, I think those are the two things we think about the most, right? So we have authentication, that's the who, right? Somebody's logging into your app or something, and then they access something, right? That's the what. What do they have access to? So that's the authorization. So a story I like to tell is I go to Matt's house, I knock on his door, and he maybe peeks through the peephole, and he identifies me, right? He's acknowledging who I am, and then he authorizes me to come into his house and maybe sit on his couch, right? But he's not going to let me open his fridge and go through his cupboards. I don't know. Maybe he will, but for the sake of the conversation.
But I got plastic on the couch, so it's obvious, right? They shouldn't sit there.
Right. So, but Matt also needs to be concerned with the overall security of his house, right? So if he leaves a window open and I crawl through the window and I can have access to anything I want in his house without him knowing. So just like that, our applications also need to be aware of all of these concerns. So we're going to talk about everything from the front end all the way down to the back end infrastructure. So why should you care, right? Who wants to build more secure apps? Anybody? A couple of you?
Anyone not want to build more secure apps?
All right.
You're in the right room.
Right. So Matt and I, we've been building software for, I don't know, over 20 years now, I think.
We're old.
Yeah, we really are. So we think we know what we're doing. At least Okta hasn't fired us yet, so
right.
we have that going for us. But when I started, and I'm sure it was the same for you, Matt, was if you were going to build an app that had any kind of users at all, you were storing passwords in a database. Anybody doing that right now? You can admit it. It's fine. I won't tell anybody. All right. Well, it's good. That's good. You came to the right place.
Guy in the back.
Okay, I missed that, yeah. So, but we know now that was a terrible idea, right? We constantly do these things wrong.
So I wanted to start out with giving you a brief history of auth. The first password was actually invented in the 1960s. It was at MIT's CCST compatible time-sharing system. And the funny thing, it was hacked in 1962. And the bug was to display all the passwords in 1966. And so if you want to look for a Wired article about it, just Google for first password and you can read all about it. And then in the 70s along came hash passwords, and you could use bcrypt or not. I didn't want to talk about the 70s. Bcrypt is sooner than that, but basically, we got into from hash passwords to RSA algorithm in 1977, and so this was a big deal because it gave us public key cryptography. And before that, cryptography's been around since, back in the 1600s or even longer than that. It was always a key, a code book that went with the knight, to the new kingdom or whatever, and that's how they decoded the messages. So the RSA algorithm in 1977 was the first time that you could do it publicly and you had public and private keys. And then along came SSL in 1994. Netscape had it. They were the ones that invented it. Version 2 came out in 1995. Version 3 in 96. So you can tell there were some kinks to work out there. And then TLS came along in 1999. And then in 2006, we got SAML 2.0. How many people use SAML today?
We'll talk about you in a minute.
How many people use SOAP today? Still got a couple. Okay, curious. All right, and then we got into OAuth in 2012. That was the first OAuth 2.0. We had OAuth 1 in 2009 and 2010, but then everyone realized it was a little complicated, and a bunch of corporations wanted to get involved. So that's where OAuth 2.0 came out. And then we got OpenID Connect, which added authentication to OAuth. And then we got Pixie, which made it so OAuth could be used in mobile devices. And basically, this kind of shows you that it's constantly evolving, right? There hasn't been anything major recently, but Pixie is 5 years old. And some of our favorite frameworks, Spring Security, Quarkus, they just added support for it like this year, or actually this month.
Yeah, I was going to say this month, yeah.
So
really.
even though a standard's been out there for like 5 years, right, these frameworks are still catching up, and there's a lot of work to do.
All right, so sometimes it helps to define some sort of personas, so you kind of know where you fit in these stacks and sort of the concerns that you should be paying attention to. Some of you fill multiple roles, and I know I do, but it's still, even if you don't, it's still a good idea to have an appreciation of the other types of roles and where things can go wrong, right? So just take, for example, secrets, right? So we know your front-end application cannot keep a secret, right? Your browser can't keep a secret. Backends can keep a secret, but they still need to be cautious of that, right? You don't want to log those. You don't want to leak them elsewhere. And then our DevOps folks or anybody doing any sort of automation needs to take these secrets from some maybe secret management store and get them to our application, right? And then maybe the paranoid security folks are just surprised that you have secrets and access to secrets at all. I don't know. But as we go through this, we're going to provide some recommendations along the way.
So now we're going to get into app auth security patterns. So I think it's important to talk about auth security patterns, because there's general security patterns. I've written several blog posts and done presentations on like microservice security patterns, and there's some general things that you should always do, right? Always use HTTPS. Like with Let's Encrypt, right? It's very easy and very free to do, so you don't need to buy certificates like you used to. Always scan your dependencies for vulnerabilities. If you're not doing that, start tomorrow. And keep your OSS frameworks updated. Now there's a funny story there, because the recent Log4Shell and Spring4Shell, if you didn't keep them updated, you were fine, right? So the following patterns apply to app developer personas. And so what kind of apps are we talking about? Specifically web apps, single page apps, and mobile apps. And a web app is quite different from a single page app or a mobile app. When I say web app, I'm talking about traditional MVC apps, like something you might have created with struts, JSF, like Spring MVC, Wicket, right? Any of those that really don't have any JavaScript unless you intentionally went and added it. And a single page app is, we call them spas, right? They're built with JavaScript frameworks like Angular, React and Vue. And I know Angular doesn't support JavaScript, it's just TypeScript, but it's all JavaScript in the end. And even if you're server rendered, right, you're doing like Next.js or something like that, you're still JavaScript when it gets, to the client. So, and mobile apps are deployed to like phones and tablets, and you even see some on TVs now, right? You just can't say iOS anymore. You have to talk about, tvOS and stuff like that. So the first pattern we want to talk about is
basic authentication. Anyone still using basic auth? Like a browser pop-up? Yeah. So this used to be really common a number of years ago. The great thing about this is it's built into your browser. I don't have to write any HTML for this. This is great. However, it's not so great because it also doesn't support any way to log out. There's no MFA or any other kind of credentials. It's just a username and password, and that's it. And it's also pretty easy to do wrong, right? So basic authentication is not encrypted. It's only encoded. So you need to treat those values like they're plain text. And it also means you need to make sure you're using TLS on top of that, which you should be doing anyway. But yeah, so it also means our applications are dealing with users and passwords, which I talked about a few minutes ago is generally not a good idea. So what do you think of this, Matt?
So let's move on to the next one. Form-based authentication. So when I started writing web apps, this is back in like 94, 95, it was quite a while ago. Form-based or basic authentication was very popular for the reasons that Brian stated, right? It was very easy to use, and It was great until the client that I was working for basically was like, can we log out? Where's the logout button? It's like, well, you close your browser. And they're like, what? And so that's when they ask for form-based authentication, right? So they request form-based authentication. And as widgets from identity companies like ours become more popular, this can also be called embedded authentication, right? Instead of redirecting to Okta or redirecting to Google to log in, you're embedding their widget like in your actual app. But notice this, like Facebook and Google login are very popular for logging in, right? They don't have embedded widgets, right? You can't use a Google widget on your web page like you can an Okta widget. So we're basically bashing on Okta here. But we're like, I don't know if you want to do that, but customers love it, people love it because it can give their app the look and feel, right? Or their login page the look and feel that they have. So, you know, a quote from our friend Keith Casey is login pages don't earn raises, right? And so if you're using form-based authentication, it's highly likely the hosting application can access your credentials. And that's what we really do when we say we fight for the users, right? We want you to be building apps where the actual application that you're building can't access your users' credentials, so you can never be blamed, you know, for breaching or giving their information up. So it's bad for users, right?
Let's put another X on that one, huh?
Yep. So.
All right. So we talked about we were going to get to SAML.
Right.
Right. So back in 2000, we put XML in everything we could. Right. Fast forward today, we put YAML in everything we can. So I don't know if anything's really changed in that front. Or JSON.
Like
Yeah.
JSON too.
But the XML thing turns out probably wasn't a great idea. Right. SAML specifically is complex. There's a lot of surface area. This means there's a lot of vulnerabilities. Right. SAML was created, what did you say, 2002?
2002.
2002, right? And in the last 5 years that I've worked at Okta, I haven't had to touch SAML once. Right? OAuth and OADC have filled all those use cases and then some. One common ask, I would say, is developers come to us and say, I must use SAML. And we typically think that's an uninformed opinion, right? So, you know, a security argument of we've always done it that way is not a security argument, right? So if you're building apps currently that still have SAML, that's fine, right? Make sure you keep those things up to date. But if you're building new applications, use OAuth and OADC. So what do you think? Another X?
Absolutely.
All right.
So now we move on to JWT. I don't know if you knew this, but in the spec, it's called JOT, right? JOT, they actually call it out in the spec. So a JWT string has a header, a body, and a signature, and it's separated by dots. So really, it's just a random string of characters, right, before you decode it. But it's defined by spec RFC 7519. It's had so many issues that they had to do a new RFC 8725 in February of 2020 to list the best practices, right? They were like, you don't have to conform to the spec, just conform to this one. And so there's 9 different threats and vulnerabilities listed in that RFC. And it's often used as a replacement for sessions, right? To make an app stateless, because then you can scale better. But JWT isn't really meant for auth. It's a format for transferring data, right? But people are using it kind of wrong that way. And there's a website called How Many Days Since JWT.algnunvuln.com. And it's been 74 days from the Brazilian Ministry of Health was hacked because they weren't doing their JWTs correctly. So JWT,
yeah,
not really.
Not so good.
We had the base.
Right. 74 days, though, that's probably the longest stretch in a while.
Well, the last time Brian and I did this, I contacted the guy who runs that website, and it's been 30 days since something, and so he now has something on the website that's like, contact me if you found a newer one. And so we have a couple other resources on that. This is written from a former colleague of ours, Why JWTs Suck as Session Tokens. I send this to people a lot, and most of the reason is because if you're generating like JWTs in your app, that's slow. You're slowing things down, and then you're parsing them in the client and everything like that. And basically, you're trying to be stateless so you can be fast, and you're slower because you're trying to be stateless. And guess who uses like session cookies like the rest of us have for 20 years? Like all the FANG companies, right? So even though you might think it's faster, we don't actually believe it is. And we do plan on doing some tests eventually to show you, like in a JHipster context, it supports all these different, types of authentication. So is it really faster? And then there's what do we do about JWT? If you download this presentation, I upload it to Speaker Deck, and we'll give you a link at the end. You can click on like these links and go to those actual articles. And basically, they recommend protobuf tokens after all other API tokens. And personally, they said we have a hard time recommending developers build a custom token format and dealing with crypto themselves. And then the folks on the podcast are crypto experts. So it's an interesting discussion. We recommend you use it. But basically, like, JWT is not the silver bullet that a lot of developers tend to think it is, what we're trying to say. But we do like another one.
OAuth. Anyone use an app that's ever used OAuth before? All right, everybody. Has anyone ever logged into Google, GitHub, any of those sites? I don't know, I think Slack, yeah, everything, right? So everybody here has used OAuth, right? Matt and I actually spent a lot of time talking about OAuth and OIDC. So the TLDRs, sort of Matt mentioned earlier, is OAuth is authorization, and OIDC is an extension on top that adds the authentication, right? So this is Yelp, right? So if you go to Yelp and you click on one of these social buttons, right, you get redirected to Google, right? Google is the only person that I send my Google password to, right? They're the only ones I would trust with my Google password. I interact with Google, maybe I do some MFA, whatever it is, and then Flow returns back to Yelp, and then Yelp reaches back out to Google or whatever the IDP is and makes sure that that went successfully, right? And oftentimes we think about this in the context of social login, but Google uses this for Google applications, right? Or your custom, whatever in-house application could use OAuth the same way. So it's not just social auth.
And I think we should mention that Google is the identity provider in this case, and there's nothing in OAuth or OIDC that talks about how they should validate their credentials after they've displayed like the login page, right? That's up to the identity provider how they want to do that.
So the best part about all of this, right, is Yelp never touched my password,
right?
Which is really key here.
And then the cool thing about having someone else like do your authentication or using an OAuth server, like it doesn't have to be someone else. You can do it with Keycloak, right? You can stand up a Keycloak container in Docker if you want, and it'll have all these same capabilities. So you can add MFA, right? Multi-factor authentication. It's identity verification technique. It can be almost anything, right? It can be SMS. It can be a phone call, right? It can actually be like YubiKeys. Brian has a YubiKey here. Your phone can be Okta Verify, or it can be like Google Authenticator, right? There's so many different factors. And so the factors typically fall into three categories. Knowledge, so something you know. Security questions, which are terrible, right? So watch out for the Facebook or Twitter polls where they somehow ask you your mother's maiden name, right? It's not a real poll. It's trying to get your information. Possession, something you have, so that's the phone or the YubiKey. And then inherence, like something you are, the biometrics, right? Face ID, Touch ID, those are very handy if you have those on your devices. And then my dad, it's kind of funny, like it can also bite you in the ass sometimes because my dad lives up in rural Montana and he was into Bitcoin and stuff for a while. He had him in Coinbase and he had enabled multi-factor authentication, but because of where he lived, he could never get like an actual text message or SMS. And so he wasn't able to access them for months because of multi-factor authentication with SMS. But I think it worked out for him because that was the time where it was going up a bunch. But yeah. And then, SMS can be compromised. Apps like Google Authenticator, Okta Verify are best. I already said all that. But another thing you might want to know is 1Password works too. So 1Password has the ability to go in there and add like another factor, right, as part of your storing. So I find it super convenient because I'm already using 1Password, and they will actually populate the field for you. So that can be very handy if you're on a mobile device. And speaking of 1Password, if you actually are building your own login forms and you somehow block a password manager from putting in the password, you're doing it wrong. Like allow that person to, copy and paste into there or paste in, from an app.
Yeah, make it easy for people to log in using long passwords. Anyone ever typed in a 36-character password into your television? Right? Right? Yeah, it's not fun.
Not fun at all. And so, this is how it works, right? It goes from all these things that we talked about. And then the next thing, big thing is what, Brian?
Passwordless.
Right.
So I mentioned a whole bunch of times that you really don't want your applications touching user passwords. Come to find out, users don't want to touch passwords either, right? So during the pandemic, I spent a lot of time playing board games online. My family plays Ticket to Ride a lot. Anybody play Ticket to Ride? All right, yeah, all right.
It's a great game.
So my mother and sometimes my father forget their password almost weekly. And I go through this whole thing where it takes me an hour to go help them, walk them through over the phone how to reset their password. They go to a different device, get it, log in and get an email, and it's a pain. One time we actually didn't even get to play the game because they spent so much time resetting their passwords. So the alternative here is some sort of passwordless experience, right? Okta brands this as FastPass, but there's other things, right? If you ever used a magic link to log into Slack, right? Slack is trusting that your email provider has done a good enough job verifying your email. But there's also other things like biometrics or your phone or your Face ID or all those things, right? So, and I have a YubiKey that can work too. So we really need to move to the world of users not having passwords
But that's going to require that you embrace like multi-factor, and so maybe in rural parts it'll be a little harder. But the whole satellite internet, what's that?
Starlink.
Starlink. A friend recently got that lives in like the rural mountains of Colorado, and it's changed his life. It totally works well. So maybe in the future everyone will have internet.
I'm moving further into the sticks, I think.
So now we want to rate these, right? We talked about all of them. So this is AppAuth, and basically we give HTTP basic like 1 star, right? We give embedded auth 1 star too, because we think if you can access that user's credentials, that's not great. SAML gets 2 stars. JWT Auth similar. And then OpenID Connect is 4. If you add MFA on top of that, it's great. And if you're going to do passwordless, with Magic Link or something like that, we give that 5 stars as well. So on to the tired and wired.
Yeah, so tired and wired. So, I think it helps to go through some of these things and talk about what's good and bad, right? Matt and I work at Okta, so it always seems like we're drumming up business. But as Matt mentioned, you don't have to use Okta. You can use something else, right? Our big thing is you really just don't build that yourself, right? Matt mentioned earlier, you don't need to be, your applications, your web apps don't need to be stateless. Session cookies work, right? Sessions work. All the FAANG companies use them. If you have a reason to avoid them, that's fine. There are legitimate cases, but that shouldn't be the default. When possible, we always recommend moving the auth to your backend application and not your SPA, your front end. If you're building a SPA without a backend, I get it. You have to add auth somewhere, right? But just watch out. There's an OAuth implicit flow that's been deprecated, so you want to avoid that. It's been replaced with the OAuth auth code flow with Pixie. We can talk about more of the details about that in a bit, but basically we're treating our browsers the same way as we would treat a mobile application. And always watch out for sensitive data in your URLs. So URLs end up in log files, they're in your browser history, they're everywhere, right? And even the Java servlet spec still allows for the session ID in your URL. So you make sure you turn that stuff off if you're building those types of apps.
So now on to API auth security patterns. So these apply to the API, developer persona. So anyone that's doing like not front end pretty much as a developer, right? They can also apply to security folks that are maybe auditing or reviewing your code. I typically like to say they're back end developers, right? For this audience, you're likely a bunch of Java developers, but could be Node, Python or .NET. And you're worried about connecting services together, and you probably really hate JavaScript, right? That's one of the personas when someone calls themselves a backend developer. And you think that SPAs are the worst thing that ever happened to the web, and long for the days of Spring MVC, and you might even like JSF. So in this section, we'll talk about how patterns for securing clients to your APIs, as well as how APIs authenticate to each other. So the first one we want to talk about is HTTP basic again, right? It is a thing. It's typically used with a static username and password, and it's likely shared between services. It's also the default for Spring Cloud config, and this is why I mention it, is because when you include Spring Security on the class path, for instance, here's a default from JHipster, it actually puts that information in there. And like Brian said, it's just a base 64 encoded string, right? And so you can see here it's just a raw string. So we're not too worried about this in the JHipster context because, this is stored on the server. Unless we're putting it in source control, it shouldn't be an issue. But try not to put like any sort of secrets in source control. And the cool thing is Brian and I probably need to write a blog post on it, but Spring Cloud Config now supports OAuth instead of HTTP basic. But in JHipster, we still use it as the default, so that's why we kind of mention it here.
All right, you know what's next?
Tokens.
Tokens. So has anyone ever been to New Hampshire? Wow. Okay, let's go. So Fun Spot in New Hampshire is the world's largest arcade. I live in New Hampshire, not too far from there, and I think it's a great explanation of what tokens are, right? So in the case of Fun Spot or any arcade, you show up and you give them your credentials, which is your $20 bill, right? They give you a cup of tokens, and you use those tokens to go access their resources, right? And in my case, I play Arkanoid a lot, but maybe some skee ball or whatever. But just like our web applications, we need to avoid using, maybe static API tokens, right? So in the case of FunSpot here, they just have static tokens. Those tokens are good everywhere. Someone could walk by and steal my tokens. There's no way to rotate them. They're good for every machine. I can access every machine in the building with any of these tokens. So for our web applications, we need to make sure that the tokens is actually just a part of the overall security pattern, right? You need to be able to rotate them, expire them. So just make sure you're using something like OAuth if you're using tokens or some other way to deal with these types of problems.
But then if you're a developer that's like interested in OAuth, understanding what it is and all the different specs or RFCs can be very complicated. So a story I like to tell is when I started working at Stormpath, which was later bought by Okta, I created a module for JHipster that basically integrated Stormpath. And at the time, Stormpath did mostly embedded auth, so it rendered like server-side pages, or maybe it rendered, using Angular or whatever. But it was very easy for me to add that in there and make it all work. I think I did it in a few days. And then we got bought by Okta. Stormpath went away, and I wanted to refactor JHipster to support Okta. And so what I saw was JHipster had OAuth support. And I was like, sweet, well, I can just configure it to use Okta instead. Well, what I found was it had its own authorization server. Using Spring Security, it was like enable server config or something like that. There was some annotation used. So it was emitting its own JWTs. And then in the client JHipster in like AngularJS or Angular at the time, it had a client ID and a client secret, right? And that's how it was doing OAuth. And you see that a lot. You see a lot of tutorials out there that talk about OAuth, and then they use the resource owner password flow, which is basically sending a username and password. And you're like, like OAuth supports that, but man, it's a bad idea, right? And so what we like to do is basically say that, a lot's changed since OAuth 2.0 came out, because that was 2012. The iPhone was brand new, or not the iPhone, but the iPhone 5 was brand new. The latest browser from Microsoft was called Internet Explorer 9. Single-page apps were called Ajax apps, and CORS was not even yet established as a standard among W3C. And so things have changed a lot in the last 10 years. And what we've got is OAuth started out as a list of 4 grant types. There was authorization code, which is often used in server-side apps because there was a client secret involved. Implicit, which was for SPAs, right? Because CORS didn't exist, so they were sending it back in the URL. There was the password one, which you see in tutorials, and you're like, oh man. The reason that password grant was added is so Windows 3.1 could use OAuth. It was to basically allow people that couldn't pop a browser to actually do it, right? So if you're actually using it now, well, you're doing it wrong. Client credentials is the one that's really important for APIs because it allows APIs to talk to each other without user interaction. And so the Pixie extension was created for mobile apps in October 2017, and then devices without browsers became very popular, right? Smart TVs, that's a pain in the butt to type in, your password to. So now your TV will prompt you, Netflix, it says go to this URL, you go there, and in the background they're polling for you to actually do that, and that's all using device grant. And that wasn't even created till like August of 2019. So over the years, it's had things added and removed, and now looks more like this. And the security BCP mentioned there is security best current practice. And so what we like to say is it basically drills down to OAuth 2.1. And I believe there's a talk here on OAuth 2.1. It hasn't been like finalized or anything, but these are the things they're talking about. They're just authorization code flow, which you can do in a server-side app, but if you want to do it in a client app, you can do it there as well. It just uses PKCE, right? Proof key for code exchange. And then there's a client credentials for API. You should never use client credentials if you actually have user interaction. And then there's a device grant, which you can use for CLIs, TVs, like all the different devices. And so you can visit oauth.net/2.1 for the latest information about that effort. And then I mentioned, client credentials, OAuth client credentials. So the goal here is to allow two automated servers to interact securely. And so it does this primarily by replacing, HTTP basic with a token-based authentication scheme, and it reduces the number of requests. And basically, it mitigates the risk by having the client request an access token from the authentication server, and it does a very similar like OAuth dance, right? But you need an IDP for the auth server, so that's a little different than HTTP basic, where you just had to configure it on your server or your other app. And then you get into the question of, if you're doing like client credentials for microservices, do you have one auth server that talks to 100 microservices? That's easy to set up, right? Like you just have one place and you register all your clients there. Or there's another pattern called where you do one auth server for each service, right? And like Okta and many other providers allow you to add as many authorization servers as you want, but you know how security is. The more levels you add, like the more complicated it becomes to manage. So there's a thing called, token exchange? Yep. That's like another part of OAuth, that if you have that set up where you're doing one-to-one for each service, you have to like allow them to trust each other and stuff. So we typically recommend the one-to-many because it's easier to implement, but if you want to get super secure, you can do one-to-one.
So anyone think that whole bit was a lot to take in? No? All right, you guys got it. Awesome. Well, if you do, and you just don't want to raise your hand, one of my favorite patterns is an API gateway. So has anyone ever used Nginx or anything for a reverse proxy for your app? Okay. So this is the same idea. Instead of dealing with TLS or whatever, you basically have an app, sits in front of your app, and it deals with the whole OAuth dance for you. And then that keeps the surface area of your application small. So this works great for new applications, but it also works really well for old applications. Your legacy apps where maybe it's harder, maybe you have old versions of libraries that you're stuck on, and it's hard to get newer secure libraries in there. So you can stick this in front of your application and help secure it. And there's a whole bunch of options out there. There's Spring Cloud Gateway, Kong is here, there's Nginx Plus, there's a few players in the game, but I definitely recommend checking that out.
And so if you're talking to APIs, one of the things that often comes up is it's not good enough a lot of times for your company to just develop APIs, because people don't really like writing low-level HTTP like in their code to talk to an API and process the result. So a lot of companies, and we're one of them, you create API SDKs, right? And that SDK is in Python, it's in Java, it's in .NET, and you basically write a couple lines of code to talk to the endpoint and get your data back. The only reason I'm using SDK, man, is I just like the logo here, right? It's not really related to API SDKs, but it is something that if you're an API company, you might want to consider, because your users will love it. But one of the things that we've learned is your API's got to be pretty nice, for developers to love it. So, not only develop SDKs, but also make a nice API, right? Don't make too many nested objects or anything like that. And so one of the last ones here is API encrypt and rotate secrets, right? Secrets might be an API key, a client secret, or credentials for basic authentication. The number one rule is don't check them into source control. And it's funny because we have some like Git Guardian stuff on our source control repository. So if we check something in, like the build will fail, right? And it actually gives us a warning. But I've even noticed if I check in like AWS keys, I get an email from AWS like within 30 seconds. They're like, you just checked in a key, you need to go and rewrite your Git history and stuff like that. And so, store them in environment variables at the very least. Try not to store them in source control. And that's just the beginning, right? Store them in some sort of vault, right? There's examples like HashiCorp Vault, there's Azure Key Vault, there's Amazon's KMS, or even Google's Secret Manager. So there's a lot of options out there for actually storing your secrets, not in source control.
All right, so next up, we have RBAC and ACL. So RBAC is role-based access control, and ACL is access control list. There are some subtle differences between the two. With an ACL, you have some list with some sort of user or group associated with some resource. And I sort of tend to think about things naturally more the RBAC model, where I have a bunch of users, I stick my users in groups, and then those groups represent some sort of role or set of permissions. So my privileges here. So the great thing is my application really only cares about if the permission is available, right? It doesn't care about how it actually got there. So in Spring, so anyone's using Spring Security, this generally maps back to the authorities. So definitely if you're using Spring, check that out too.
How many people are using Spring Security?
Yeah, how many people are using something homegrown? You can raise your hand. Somebody? Nobody?
Like, no.
You can tell me afterwards. It's fine. I know you're here.
All right, so let's rate these now. We got HTTP basic. We're gonna go get the same, right? 2 stars. You'll notice SAML is missing here, right? SAML doesn't do API authentication or authorization. Tokens, they're faster than HTTP basic because you don't have to calculate anything, right? Things like bcrypt, right, are slow on purpose, right? So tokens, aren't encrypted that way. And then a funny thing from CodaHail, the guy that wrote Drop Wizard, right? He gives this great anecdote that's a modern server can calculate the MD5 hash of about 355 megabytes every second, right? If your users have passwords which are lowercase, alphanumeric, and 6 characters long, you can try every single possible password of that size in around 40 seconds, right? Use bcrypt with a work factor of 12. Instead of cracking a password every 40 seconds, it'll be cracking them every 12 years or so, right? And so that's why your encryption algorithm you're using is very important. And so OAuth 2.1, we give that 5 stars. Notice we didn't even put OAuth 2.0 on here because we don't really like things like the password grant or the implicit flow. API Gateway is a great way to make your legacy apps, modern. API SDKs, those are cool, but again, your API should be, the first-class citizen. Always encrypt your secrets, right? Not just encode them, or not just put them in variables, but encrypt them. And then, RBAC and ACLs are a great way to secure your apps too, and your APIs. All right, so tired and wired.
All right. So, I've mentioned this before, but it's worth repeating. You're much better off using some existing library, right? Is anyone here, would anyone go build a JSON parser? No. Would anyone here go build a security library? No, but you probably come a lot closer to that one than the JSON library, right? So if you find yourself going down those paths, take a step back, use something that's an existing library, right? Avoid static API tokens, use some sort of short-lived access token instead. And CORS. Matt hinted about CORS before. But if anyone's not familiar with CORS, it's a way to your front ends can access your backend REST API. We've seen time and time again people just using wildcards and letting everybody access your APIs. But in general, you want to restrict everything down as much as possible, including CORS, but everything, right? So everything we do, we want to practice the least privilege principle.
Yep. And now we're on to the last set of patterns for infra auth, and right? These apply to DevOps and security personas, and they typically don't concern like app or API developers unless you're actually responsible for deploying, updating, or monitoring the code, which can happen at smaller companies. So it's very different at small companies and nimble organizations where you might actually be doing these things. So keep that in mind, and we'll talk about securing the infrastructure that your apps and APIs run on. And just a caveat for this, Brian and I, most of our experience has been with apps and APIs, and we've been sysadmins in our own homes, right? But we've never been paid to be sysadmins except when we worked at those small companies, and we're by no means like DevOps experts. So on to the first one.
All right, use Linux, right? I'm not even sure this needs to be said anymore. But I know when I started out, running Java web apps on Windows was definitely commonplace. And we always run into problems, right? There was weird threading issues or file handles, or there was always some sort of issue, right? But automation is also slow. I worked at a big Fortune 500 company a few years back, and we had racks of Windows machines, right? Hosting a big popular Java web app, and it was painful to automate those things, right? You have to tweak the registry, and I don't know, it was painful. We were eventually moving to Linux and trying to clean things up, but it was still hard. And I'm not trying to pick on Windows, right? I know the Windows world is getting better. People complain about it less anyway. But as a Java developer, I think the vast majority of the libraries you're consuming are at least tested on Linux first. So, make sure you're using that strong foundation.
All right, so the next one is SSH with keys. So SSH protocol, also referred to as secure shell. It's a method, right, for securing remote login from one computer to another. It provides strong authentication, strong encryption. Works in the client-server model, which means that the connection is established by the SSH client connecting to the SSH server. And basically, user authentication is most commonly done with passwords and public key authentication. And the latter is primarily used for automation and single sign-on by sysadmins. So one of the biggest challenges with SSH is actually cleaning up the unused keys on your server that aren't being used anymore, right? That's why you want some sort of automation, like when people, leave your company, they're deprovisioned, their SSH keys are removed. So make sure and audit SSH usage and clean up those when people do leave.
Certificates. So I think that the little unsecure lock or unlock or whatever it is in your browser is one of the best things that's happened in a while for browsers, in TLS in general. But I will be the first to say certificates are a pain in the ass, right? Does anyone disagree with that? All right. They're a little better now, right, with Let's Encrypt and everything. Typically we handle these things like with a reverse proxy or something, so we don't really have to touch them a lot, but they still come up from time to time, right? So I know I was helping somebody, I forget who it was, deploy a Heroku app, and they needed to set up a custom domain with TLS, and we had the whole thing deployed in 5 minutes, right? So that's much, much better than it was in years past, where you have to get like a procurement order to go afford an SSL a TLS certificate, and then you'd have to install it manually usually, and then forget about it in 3 years, and then it expires, and someone calls you up in the middle of the night, tells you that it's expired, and it's a bad day, right? So in recent years, all this has changed, right? So Let's Encrypt, those things expire every, 3 months? And you typically rotate them every 2. So you have to automate them, right? So you never forget about them anymore. And browsers only allow certificates to, their sign-in keys to only last for a year now. So again, we're sort of forcing us to get into better habits. And if you're doing anything on localhost, I think MakeCert is one of my favorite tools for making sure even your localhost development is also secure.
So that's MKCERT. If you Google for it, you'll find it on GitHub. Works really nice. And then, the next thing we want to talk about is SSO for servers, right? Traditional options are Active Directory, pluggable authentication modules known as PAM, and vaulting. And Active Directory is out because we recommended Linux, right? So that was easy, right? And then pluggable authentication modules have been around since 1997. Basically, I was taught that PAM originated from Sun Solaris, and it does appear that the first enterprise use and popularization occurred there. And as the A in PAM indicates, PAM is about authentication. In most cases, when you log into a system via console or from a network with SSH or cockpit, PAM is involved. And it doesn't matter if the user accounts are held locally or in a centralized location, right? For as much as it is used, it is not common to manipulate the PAM configuration files directly. Other utilities do this for you. So there's a lot of PAM modules that have been written for Linux over the years.
All right. So don't forget to scan your images, right? So Docker, scan, and then your image name. That'll work for you. So over the years, I think we got really good at patching servers. Then we moved everything to containers, and at some point we sort of forgot we needed to do the same type of maintenance. I don't know. Hopefully that's not a problem for any of you. I'm sure it's not, right? Nobody? All right. So when I started, you'd have your OS, you drop your web server on there, Tomcat, WebLogic, whatever, and you drop a WAR file in there, right? So you had basically 3 buckets to manage, and then we got smart, right? We started embedding the web application and the web server together. So you have like an embedded Tomcat in a jar, and that's great. So now you have your OS and your jar files. You have two things, but you're still managing all those versions, right? And then we put all that stuff into a Docker container, and we still have the same bits. They're just reorganized, right? So you still have to do all the same types of maintenance and keep things up to date. So make sure you're scanning your images. There's a bunch of tools out there, like the one from Docker, which is powered by Sneak. I think Red Hat has Clear, and I think Dependabot will help you out too. And you want to keep everything small in general. Like your Docker images, you want to keep them small. And as we think about this, think about security at all the layers of your app. That includes the layers of your Docker containers.
The next one is know your cloud and cluster security. If you're using Kubernetes, you'll want to know all about that. And buying a box of DevOps is not quite enough. And so there's the 4 C's of cloud native security. There's cloud, clusters, container, and code. And each layer of the cloud native security model builds upon the next outermost layer. So the code layer benefits from the strong base, right? Cloud, cluster, and container security layers. But you cannot, safeguard against poor security standards in the base layers by addressing security at the code level, right? So that's just the beginning point. And so if you go to that link at the bottom there, if you download these slides or Google for the 4 C's of cloud native security, it actually talks about popular cloud provider security docs, and they have links to Alibaba Cloud, AWS, Google Cloud Platform, IBM Cloud, Microsoft Azure, and vSphere. So other Kubernetes tips are scan your Kubernetes YAML on a regular basis, because even though it's in production, like you still want to make sure what's in production is working. Update the API version when new versions come out. Create PRs for outdated YAML. It's similar to Dependabot. That should be happening for your YAML files. And basically, Kubescape is the first tool for testing if Kubernetes is deployed securely, as defined in, get this, Kubernetes Hardening Guide by NSA and CISA. So there is actually government in the US, like docs and guidance, where they tell you to use this Kubescape thing. And it's actually available on GitHub, so you can go Google for it and find it. The other thing that I like to talk about when it comes to Kubernetes is Kubernetes secrets. That's the worst name that they ever gave to what is actually a base 64 encoded string. So they call it Kubernetes secrets, but you can uncode it or decode it with like a browser or something on your OS, right? And so if you want to store your secrets in GitHub, a better solution is use Bitnami's sealed secrets. And that actually is composed of 2 parts. It has a cluster-side controller and operator, and it has a client-side utility called KubeSeal. So if you're using Kubernetes secrets and you think you're doing a good job, you're not. And of course, you can use something like HashiCorp Vault, right, or Google Secret Manager or something like that, and that'll be just as good, if not better. And so there's actually a 250-page Manning book on this subject called Securing Kubernetes Secrets. So if you're doing Kubernetes, check that out. Here's the sealed secrets thing, and it's available on GitHub. I've used it with Google Cloud, and it worked great. Like it was one of those things where you run some commands with a little bit of YAML, and then it all works, and you're like, wow, that's cool, because you're storing encrypted secrets, and you can do it in GitHub, and even though they're public, like people can't decrypt them.
All right, so we got to move things along here, I think. We got a couple minutes left.
Like 5 minutes left.
All right. So automation is key here, right? So this image is one of Tesla's factories. Anybody who has read anything about Tesla and their sort of automation journey, let's call it, knows they ran into some problems, right? And if you've ever done any sort of automation, that first one is pretty hard, right? But then as you get past your first one, the second time you automate something, you really start picking up steam, and eventually it's really the path forward, right? But in a recent podcast with Mark Shuttleworth of Canonical and Kelsey Hightower of Google and Kubernetes fame, right? They were talking about how Kubernetes is really kind of getting to the point of it's a way to abstract away the OS, right? But we're not there. It takes a lot of work, a lot of automation, right? And a lot more YAML, right? So automation here is the key. So we want to automate everything. And I don't care what you're using, right? If you're using Terraform, CloudFormation, Chef Puppet, whatever. Automation is the only way to get your application tested, deployed, and rolled out every time there's a vulnerability. Does anyone know about how many vulnerabilities show up every day? No? It's about 50, right, on average. Obviously, some days there's a little fewer than others, but on 50 every day, right? So given that some set of those are probably going to affect your application, you need to be able to get those changes into your application or your OS or wherever in the stack it is, and get them, tested, rolled out into production. And similar with personnel changes. So there's been a lot of tech turnover in the last couple of years, or the last year anyway. And so when somebody leaves, how long does it take you to revoke access? All right, are you sharing secrets with your applications? If something happens to one of those applications, how long does it take you to roll out a new version with a new secret? Right, all of these things need to be automated. And for on-prem options, there's always cloud providers always have some sort of on-prem option. That, like Okta has Okta Access Gateway, and Auth0 has the private cloud, but there's some way to test your applications using these things.
Right, and so now we get to rate them, right? Like we said, we aren't DevOps experts, so that's probably the reason we gave like so many stars to all of them. But Linux, 5 stars, right? SSH with keys, 3 stars because of the revoking thing. Certificates, 4. SSO for servers, 5, and 5 for the rest. And so, keep in mind that we don't pretend to be experts, but we do have a lot of colleagues that are. So we sent them this stuff, and we got a lot of feedback from them. And so, tired and wired?
All right, keep your images small. Less stuff, less surface area, less chance of there being vulnerabilities. Do not embed your secrets in your applications. Keep them external. Use something like HashiCorp Vault or one of the other tools Matt mentions. Don't share your credentials. That way you can limit access to what is actually needed.
Also, you can share credentials if you get like a 1Password team account, right? That's how our team shares credentials, right? So at least do it that way if you're going to do it. Don't put them in a spreadsheet, right? And leave it on someone's machine. So action. You've learned a lot of plethora about different, security patterns for your apps, APIs, and infrastructure. So now we're guessing that you're like us and you're developers, DevOps, or security experts and want to automate everything. And we'll give you some advice for codifying these patterns.
All right, so write less code. It's an easy way to write less vulnerabilities, right? Just write less code. So I'm not talking about the no-code buzzword, right? But just use frameworks that bake in all of these ideals, right? So, instead of writing something yourself, maybe use something like Spring Security or whatever framework you're using. It probably should have some sort of security component. If it doesn't, try to find something else.
And I like to say take it a step further and use something like JHipster that generates your front end for you and has built-in support for OIDC, CSRF, security headers, like it gets an A on securityheaders.com, and everything you need to build a secure application out of the box. But funny story, we had a vulnerability just last week where you could put in the URL like a drop table statement, and because of R2DBC's criteria API, it would actually drop like that table. So we fixed that since. But even though we think we're always secure, sometimes there's things that crop up.
Speaking of security headers, though.
Speaking of security headers, we checked out Devnexus.com, and they get an F. All right, so maybe we need to talk to Pratik or Vincent and tell them. But it's important for spas more than anything because they're testing like your content security policy and making sure you're not doing unsafe evaluation of JavaScript and you're doing everything properly. But you can also, hire pen testers, right? We recommend that. There's a plugin for Chrome called the Implicit Flow Detector that will see if you're using implicit flow. There's a Gatling can be used to load test APIs and, enhance authentication and performance and error handling. And, audit your server access log, right? Clean up your SSH keys.
Oop. All right. So I think Dependabot probably has more commits in my repos than I do now, which is great. So definitely keep things up to date with a bot or something. I'm also a big fan of static analysis tools. I love spot bugs, which used to be called find bugs, which is why find sec bugs has the name it does. But that's more the security side of spot bugs. So check out those tools. There's Z-Attack Proxy, and I mentioned a bunch of these other tools before. From Red Hat, Sneak, Sonatype, and JFrog has tools that will help scan your apps too. And we need to be ready. Once we find a vulnerability, we need to be ready to roll that out because they're going to come up. Everyone's heard of the OAuth Top 10, right? I hope so. So there's a whole bunch of other resources from OAuth 2. There's like 200 projects over there. They have cheat sheets. Go check them out. They have one for GraphQL, Docker. There's a whole bunch of things, right? All right. One last quote, I think, right? We have time for this?
Yeah.
So the OAuth top 10 really hasn't changed that much in the last 10 years. Now, I know this is actually just updated, whatever, in the past year or so, but this quote actually goes on to talk about how SQL injection is still at the top of the list, even though we've done all of this stuff to educate folks, right? As Matt mentioned, the SQL injection problem is still alive and kicking.
This happened, yeah.
But now, we've moved SQL injection, or injection in general, down to 3, right? So the quote is still pretty accurate. But this means we're doing something wrong, and we really need to build security into our applications at every level and be secure by design.
So if you want to learn more about the things that Brian and I write about, we write a lot about Java, a lot about Spring, a lot about Spring security. That's at developer.okta.com/blog. We have OktaDev as a handle on Twitter, YouTube, and GitHub. And thank you for coming. We really appreciate your time, and may the Auth be with you.